Welcome. Today's lesson is about working problems using all four different triangle centers. I have an example of each type for you. The first one is formed by angle bisectors. As you recall, the intersection of the angle bisectors is called the incenter. If you have an incenter, you can have an inscribed circle. That means you have a circle here whose center is right here that passes through this point, and this point. They're tangent to each of the sides of the triangles there. Now, you're given in this triangle, you're given angle bisectors, and you're told that segment DT is 5, DP is 7, and you're to find PU. So angle bisectors means that these two angles are congruent, these two are congruent, and these two are congruent. We also know that if it's an inscribed circle, which it is, it can be, then the distance from here to here is a radius. Just like from here to here is a radius, and from here to here is a radius. That means that these points, S, T, and U, are all points of tangency. That means they form a right angle if you connect that point to the incenter. So, I'm looking for this segment right here. I know that this is 5 and this is 7. If this is 5 and this is 7, I can find this. I can find PT. Once I find PT, I know that's the same as, it's congruent to PU. So I've got my answer. So, I use the Pythagorean theorem, a squared plus b squared is equal to c squared. Place my hypotenuse first. That's the 7. A squared, A is 5, and we're looking for b squared right here. 25 plus b squared is equal to 49. Combine like terms, so we subtract 25 from both sides, which gives us b squared is equal to 24. And take the square root of both sides, which gives us b is the square root of 24. We must simplify that. Two factors that give us 24 are 4 times 6. This is a perfect square. So the square root of 4 is 2. I move that to the front, and what I have left is the 6. So my final answer is, since PT is equal to PU, I substitute this for PT, and I find out that PU is equal to 2 times the square root of 6. That's for angle bisectors. The next one is for perpendicular bisectors. Perpendicular bisectors cut each side into congruent pieces and form right angles. So each side is congruent, each of these segments is congruent, each of these is congruent, and each of these is congruent. And since it's a perpendicular bisector, it will form each of these will form right angles. The point of congruency is called the circumcenter. This allows us to have a circumscribed circle. That means if we use this point as our center for the circle, that means the distance from here to here, from P to B, is going to be congruent to P from P to C and P to A. That will be your radius. And I can have a circle that passes through each of these 3 points using this as the center. That's the circumscribed circle. Now, I'm told that AB is 10, PM is 3, LP is 7, and I'm to find BM. I'm looking for BM, this distance right here. Well, I'm told that this is 10, AB is 10, so if AB is 10, that means this segment right here is going to be half of this, or 5. I was given this is 7, and this is 3. If I connect points B and P, it forms 2 right triangles. BP is the hypotenuse for this triangle over here, and BP is also the hypotenuse for this triangle over here. That means they're going to be congruent. So I can say A sub 1 plus A sub 1 squared plus B sub 2 squared, these two numbers, is equal to C squared, this hypotenuse squared, which is also equal to the sum of these two numbers squared. That's B sub 2, A sub 2, and B sub 2 squared. Now, since this and this are equal to the same thing, they are then equal to each other. So now all I have to do is substitute. I know that a sub 1 is 5, b sub 1 is 7, a sub 2 is 3, and b sub 2 is this segment I'm looking for right here, segment bm, that quantity squared. Now I simplify. Gives me 25 plus 49 is equal to 9 plus the quantity, the segment bm squared. Combine like terms. Simplify, so I have to subtract 9 from both sides. Here's my 0 pair, which gives me 65 is equal to segment bm squared. To find bm, I take the square root of both sides. So bm is equal to the square root of 65. I find the factors for that. That's 13 and 5. There are no perfect squares. There are no pairs of prime factors. So it cannot simplify anymore. This is my answer. The next triangle center is formed by the medians. The median is formed by connecting the one vertex to its opposite midpoint. That means this is the midpoint, that means that these two segments are congruent. This is the midpoint connected to this vertex, the opposite vertex. These two segments are congruent, and that means these two segments are congruent. We know that this is the centroid, called the centroid, which provides the center of gravity. That's the balance point. And we know that the distance from this centroid to the vertex is 2/3 the total distance of the median. So if BV, this whole median here, is 3.9, I want to find BG. Well, I know that this piece is 2/3 of the total. So this piece, BG, is equal to 2/3 of the total, BV. Substitute what I know for BV, multiply by 2, divide by 3, and I find out that segment BG is 2.6 units. The next one is the next point of concurrency is formed by finding the altitudes. This is called the orthocenter. Altitudes are nothing more than doing a perpendicular front to the opposite side from each vertex. So the distance from here to here forms a right angle. The distance from here to here forms a right angle at this point. And the distance from here to here forms a right angle at this point. That's an altitude. I know that PR is 3, AR is 4, AB is 12, and BS is 7. I'm to find segment PS. This is a two-step problem. First of all, I know that if this whole thing is 12 and this is 4, then this part right here is 8. Because 12 minus 4 is 8. If I've got this is 8 and this is 3, I can find PB by doing the Pythagorean theorem. That's the first thing we do. Once we've got this hypotenuse, I know this leg, I can then find this leg. So, to find this dotted line here, a squared plus b squared is equal to c squared. So 3 squared plus 8 squared is segment PB squared. So we get 9 plus 64 is equal to segment PB squared. 73 is equal to segment BP squared. And the square root of both sides gives us BP is equal to the square root of 73. Prime number cannot be simplified. Now to find this segment here, Pythagorean theorem again, substitute what I know. Hypotenuse first, I know is the square root of 73. I'm looking for PS plus this. Simplify, gives me this. Move the 49 by subtracting. I get PS is equal to 27, PS squared. So PS is the square root of both sides, so PS is equal to the square root of 27. Factors of that are 9 times 3. Now I need to take, this is a perfect square, and the square root of 9 is 3. So I pull out a 3 in front, I still have a 3 underneath. So PS, this segment right here, is equal to 3 times the square root of 3. Go to Edmodo, lesson 3.21, and complete the check for understanding.